Alright, welcome back. It looks like we had some homework last time, and so it looks like you had page 651 to 652, numbers 3 through 10, 12 through 16 even, 22 and 23. I have not made answers for this that are up on the screen, but if you need to, if you're watching this after Nationals or something else, I can get you a copy of the answers to this. Otherwise, those students in class, I'd like for you to be busy on these problems. I would say, as far as the board goes, I would have one student put 3 through 10 up, because that's just so important that the students can get that up. So I'll let your proctor choose one person to kind of put that picture up there and get all the details, while the rest of you work on this classwork right here. I would encourage you to write this on the board and then have the students do these particular problems. This is page 660. You'll notice that's quite a ways away, but it'll be good for us to practice. And so didn't look like the problems were incredibly difficult, but I encourage you to do some of these problems so you get the practice in. Okay, I will pause the video at this point, and when you get back, we will start the lesson. Alright, I trust that you got an opportunity to look through those classwork problems earlier and learn a few things. When I get back, I can probably spend a little more time and talk through some of those problems. Number 2, in the quiz section, that classwork is a little bit harder. And again, I can set up a time to go over some of these. Write a note and ask me when I get back, and I'll talk about them. But those are the types of questions we're looking at. So let's talk about the 10.3, apply properties of chords. First of all, you need to remember what a chord is. So as we look down here, it says, recall that a chord is a segment with endpoints on a circle. So a chord has endpoints. Those endpoints lie on the circle itself. So looking over here, we've got a chord, CB, and AB. And so CB is here. You'll notice the endpoint NB is over here. We call that a chord. Now, if we take a circle, just any random circle, and since I don't have my ink to shape button, I just copy pasted a random circle. But if you just start drawing chords across this circle, you'll notice that as you go from the top towards the bottom, what happens progressively to the length of your circle as you get towards the center. It should get a little bit bigger each time. Now as you get closer to the bottom, you'll realize it starts to get smaller. And so the largest chord in a circle is what we call the diameter. And so when we look over here, it says because its endpoints lie on the circle, any chord divides the circle into 2 arcs. Now you'll notice in this particular example here that you got a major arc. Notice that's clearly bigger than the other. And so you'll always have a minor arc, major arc that is formed, or at least 2 arcs, let's say it that way. In the semicircle case, they don't have major and minors, they just have semicircles. And so notice a diameter divides a circle into 2 semicircles. Any other chord divides a circle into minor and major. So this is kind of the only scenario that can happen to us. All right, let's look at theorem 10.3. In the same circle, all right, so this is our new theorem. In the same circle or in congruent circles. Now remember, last time we said that congruent circles had to have the same radius in order to be congruent, or the same. In the same circle or in congruent circles, 2 minor arcs are congruent if and only if their corresponding chords are congruent. And so this particular one is, and I've lost my page here. If I've not said it to this point, you ought to be on 654. 654 will help you there. And so we're looking at 10.3. Also, if I didn't give you enough time to write all this stuff down, you can pause the video, take a moment to write some notes, draw these pictures. That'd be good. All right. So there's that. We're going down here. 10.3. So in the same circle. So what we're saying is, if you have a circle, I'm again going over here, getting my stencil. Nope, not like that. Out here. Bring my circle in. If I have in this circle, essentially, and this will be a little bit difficult, but I have 2 different endpoints, and we'll say from here to here, and I'm trying to make them the same. Forgive me if they're not exact, but if they're going to be something like this. Now, these are chords, they're straight lines, that would be attached across the circle. If they are congruent, so I push my little hash mark on it. In the same circle, if the two minor arcs are congruent, okay? So I haven't answered that, but they will be congruent if and only if their corresponding chords are congruent. So what we said earlier was that this particular chord, this left one here that you see, makes a minor arc over here and a major arc over here, and so does this one. But the two minor arcs that are formed are congruent to each other, and I can write the little hash mark there because they've cut off an equal segment. So that's theorem 10.3. All right. Let's look at example 1. It says, in this diagram, the two circles are congruent. P is congruent to Q. So here's P, here's Q. Interesting looking circles. They're giving you as little as possible information. My first question would be, what on earth is this line right here? What do we call this in a circle? It's a radius, and so that's what I'm looking for. And down here, we don't call this a radius, we call this a, okay, so it's a chord, good. And so it says FG, so I'm looking for it. This bottom line here is similar to, or not similar, but congruent to JK. So the two chords are congruent, and the measure of JK is 80 degrees. So here it is. Then it says find FG. All right, so what we just said was because these two chords are congruent, therefore the two minor arcs that were produced are also congruent. So this one over here is 80, the one over here will also be 80. So there's your solution to that particular problem. All right, let's get down here and let's do guided practice 1 and 2. All right, so they do a similar problem. Let me pull up my circle here. All right, and so this particular one has an A, has a B, has a C, is somewhere over here, because I got to try to make them about the same. And so here are my two lines, and they're cut chords. Now this particular one says 9, this one says 9. All right, because they both have the same measure, they are congruent. So they didn't put a little hash mark, although they could have. Here's a hash mark. Those are congruent. So it says if AB, the arc AB, is 110. So let's get some letters here. This is A, this is B, this is C. Okay, if AB, number 1, if arc AB equals 110, find arc BC. All right, so AB is 110, so here's our picture. Here's a 110. It says go find this one. All right. Probably took me longer to do the problem than it did for you to solve it. They're both 110 because the two chords are equal. So that's the answer for number 1. Number 2 says if AC, okay, well let me write this. If AC, arc AC, is equal to 150, find AB. So let's get rid of this picture a little bit. All right, so some of this information is still the same. So this arc right here is 150 degrees. Then it says find arc AB. Well, we don't know this one. Okay, and we know they're equal. So the thinking would be how many degrees are in the total circle? How many degrees do the arcs add up to? You would say a total of 360. And so I can set up an equation to find my value. So I can say x, which is my top arc here, say another x plus that x, plus the third one is going to give me 150. Nope. Plus 150 is going to give me a total of 360. So that's going to give me 2x plus 150 equals 360. Okay, pull this down just a bit. And so that's going to give me 2x is equal to 210. So x is going to equal 210 minus that, I'm thinking 105. Okay. So 105 is going to be the value of x, and so we find this to be 105. Now, this one would also be 105, but that's not what it was asking. It said find the measure angle or arc AB. So that's how we do that one. Pause the video for a moment, and let's do 657, number 4, at your seats. All right, at this point, number 4, you should have your particular problem. It says find the measure of the red arc in this chord. And so because the two are equal, you've got a 128. You've got 128 plus 2x. The two are unknown, and so it's very similar to one we just did. And so you're going to have 2x plus 128 equals what? Okay, so 360. And so you're going to subtract 128 from both sides. Let's pull out our calculator. So we got 360 minus, if I can find my minus sign, 128 gives us a final of 232. We'll simply divide that by 2, and we will get our final answer of 116 for each of those. But it's simply saying find that. So number 4, the answer to that question is 116 degrees, and so 116. Those are great problems because they make us use our algebra skills and really our logic skills as well. All right. Theorem 10.4 and 10.5. Let's look at those. Let's zoom this in a little bit. All right, here they are. Theorem 10.4, 10.5. We're on page 655. If one chord is perpendicular, or is a perpendicular bisector of another chord, then the first chord is a diameter. All right, so they said, let me come out of this a bit, and let's pull my circle, put this in here so I can work with it, and let's go ahead and get another one for the second problem. Okay. If one chord is a perpendicular bisector of another chord, right? So we've got a chord, so the endpoints lie on the circle. Do my best to get this. And so that's one chord, and we're going to draw another one that is the perpendicular bisector. So it's got to go through the midpoint. We'll draw that midpoint quite large here, and it's going to go through over here. So we're going to essentially make it go like this. Also, it's perpendicular, so it forms 90-degree angles here. And so it's the perpendicular bisector, so these 2 points would be equal. Well, then this chord, then the first chord is a diameter. So this particular one goes through the center. And what is the chord that goes through the center called? It's a diameter. So no matter how many, you could draw a chord over here as well, and you connect to that and you draw a perpendicular bisector through it, it should also go through the center. Notice how I dodged that. And so that's all that's saying. So if you have a chord and you draw something perpendicular to it, you will always go through the center, and that chord that is perpendicular is called a diameter. There's no end to the amount of problems you could draw like that. All right, Theorem 10.5. This one says if a diameter of a circle is perpendicular to a chord, so you have this time you have the chord, and it's drawn like so, and you've got your diameter, so you got your center essentially, and it's the perpendicular bisector to the chord. Drawing this down here a little bit. It's the perpendicular bisector to that chord, so that means it does like this, and we got this. It says if a diameter of a circle is perpendicular to a chord, then the diameter does 2 things. It bisects, so notice the marks I put there, and its arc. And so going back just one here, not only does it bisect the chord, but it also bisects the arc so that these 2 segments are equal. These 2 arc segments would be equal to each other. And so that's what they're saying. So that's what those 2 theorems are. So I'll give you a moment to write those down if you haven't already. All right, let's move on and let's use it. All right, here's example 2. I found this one interesting. This book has an interesting opinion on how this should go. I would say example 2 is just that. It's an example. Has a lot of application, but not so much mathematics involved. So it says gardening. 3 bushes are arranged in a garden as shown. Where should you place a sprinkler so that it is the same distance from each bush? Well, first of all, if you want it to be the same distance from each bush, it sounds like to me you have just defined perfectly a circle. And so we're thinking, okay, here's my center, and here is the arc that makes up my circle. So this is a sprinkler, and so I'm making my circle where these are kind of points A, B, and C. And so I'll draw the center of these bushes as, parts of the circle. And really the rest of the circle that comes down here we don't even care about. So it says 3 bushes are arranged in a garden as shown. Where should you place a sprinkler so that it is the same distance from each bush? Well, if the way you're doing this, you can actually set this up to where you simply just take a line. Now this would be real life skill. You can just simply take a line that goes across this, and you can, we'd call that line that you just drew a chord. You can simply go over here and draw from B to C. Okay, and so we're doing our best to get a line, and then bisect it. So you set up your perpendicular. You're going to do a perpendicular bisector of it. There's that one. Okay, so that cuts that chord in two pieces. Then you bisect this one as well, and so this one's going to have to go, through this same region, and also bisects this. So if you construct the perpendicular bisector, you find a diameter, but if you construct two diameters, you find a guaranteed what? Center. And so if you ever need to find a center of a circle and you have 3 points, you simply draw a line between them, cut them in half, draw a perpendicular bisector to that, and you've got the center of the circle. So you can look at example 655 to kind of see that, but it is just that. It's an example. Cool concept, really. If you ever trying to make a perfect garden, anything like that, but interesting. All right, looking at 656, let's look at example 3. It says, all right, so real math now. Use the diagram of circle E to find the length of AC. Tell what theorem you use. All right, well, obviously we're using one of the most recent theorems here, but it says that AF is, let's see if I can find my mouse, AF is 7, so we know that, and we know that this is perpendicular. Also, it passes through the center, which means if you have a diameter that passes through a chord and is perpendicular to it, which theorem that we just talked about says that is going to bisect that? Okay, you should be thinking theorem 10.5. So theorem 10.5. Now again, real life, you're not going to walk out to your engineering professor, or you're not going to walk out to your boss at Ford and say, oh yeah, theorem 10.5 said this. No one cares what 10.5 is. They care that you understand the concept. So if you have a perpendicular to a chord, it passes through the center, and not only does it pass through that center, but it is also going to bisect it. So it's going to bisect it, therefore the other side of this is going to also be 7. So this is 7, this is 7. And then the ultimate question was find AC. Well, if that's a bisector and they're both 7, AC is going to be 14. So segment AC, or the distance AC, is going to be 14 units long total. All right, I'm going to give just a moment to look through the guided practice, and we'll do them together. Page 656, let's zoom this in a little bit. I do need my circle back, so coming back from this, paste a circle, pull this over. All right, we can use this for 3 and 5. We will skip 4. You can do it on your own. Let's talk about it. So we got 3 and 5. So essentially you've got on number 3, find the measures of the indicated arcs. And so you've got a circle that has a chord that is drawn, kind of scant like this. So here's your chord. It's going to draw the line kind of like so, my best I could do. You've got a center of A, and then you've got BD that kind of comes across like so. Now, is that a perpendicular bisector? It is, so it needs to be pretty much perfect. And so I will probably move this center to make it work. So here's our center. We'll call that center A. Make that center look a little bit better. There it is. All right. So we said that this was BD, I'm sorry. And that this one down here was CE. And then the intersection doesn't have a name, but it does say that that's a right angle. So it says, for this particular one, find the measure of the indicated arc in the diagram. So it says, first of all, number 1, arc CD. All right, arc CD is going to be given. Now they did say over here that this is 9x degrees, and this down here is 80 minus x degrees. All right, so Obviously, since this is going to be a perpendicular bisector, it not only does that to the parts, but it also sets those two values of x equal to each other. So we have 9x equals 80 minus x. So we add x to both sides to get the x's together. We get 10x equals 80. Well, that's real easy. So we get divide by 10, we divide by 10, we get x equals 8. Final answer. And so that's all there is to number 3. Well, actually, no, that isn't, because it says find the measure of the indicated arc. So x is 8, but if it says find CD, we need to take that 8 and do what with it? Okay, some of you are screaming at me, but 8 times 9 is going to be 72 degrees, and so that's all there is to it. Now, I can also plug it back in over here, but that's also 72 degrees. They're equal. They're the same. Next here, so let's get rid of this. Let's look at number 2. All right, number 2 says, or number 5, I'm sorry. This one was a 3, so you all knew. And this is a 5. And so it says find CE, arc CE. Well, CE is interesting. So we know they're both 72, so 72 times 2 is going to be 144 degrees. And so that's all there is to it. Just multiply them by 2. Once you find the part of it, you'll find the whole. All right. I will give you a moment to work on at the bottom here, 657, 6 through 8. I will let your proctor choose 3 students, 6, 5, and, well, that's going to be 6, 7, and 8 to go ahead and work. Now, I'm going to talk through 8 if it's confusing, but I do want to try it. All right, so at this point, you should have paused it, and you can come back to this point, but the students should have gotten 6 and 8 done. Answers, of course, are in the book, and so let's go ahead and do number 8. Number 8 is going to look something like this, and so number 8 has basically an X on it. Okay, and so we've got a point here, we get a point here, kind of over here, something like this. So they're coming at each other perfectly, and so this one's coming over here kind of near perfectly, and it says RSTU. So R, S, you've got a T, U, and a Q right here, and it seems to say that this 6x plus 9 is over here, so 6x plus 9 is this kind of top arm, and this bottom arm is 8x minus 13. So 8x minus 13. Now, realize that these are chords and that they are, in fact, over here, this is a kind of key to the problem. This is a 90-degree angle. Now, going back to yesterday, what did we call the angle that's formed right here? RQU. You should be calling it a central angle because it's, you know, formed at the center. And so if the arc is measured at 90 degrees, then what's the measure of the center angle? Well, it's 90 degrees. Well, if this is a linear pair, how much is this? Well, it's 90 degrees. And again, linear pair, and so it's 360 all around. Which that basically tells me that this arc equals this arc, which equals this arc, which equals this arc, and therefore all the chords are essentially equal. And so I can set them up to each other, and so I'm going to get 6x plus 9. What I'm saying is that these are perpendicularly bisected. Okay, is going to equal 8x minus 13. Okay, so I'm going to subtract 6x from both sides. That's going to give me 2x equals, and I'll add that 13 to both sides, so we're going to get 9 plus 13 is going to be 22, so x equals 11. That's my x value, and it seems to say find the value of x. So my answer to that question would be 11. Make sure I'm right. Again, I'm not using an answer key to do this, and so debate and make sure that I'm not making stuff up there. Okay, let's move on. 10.6, it says, in the same circle or in congruent circles. This is going to be on page 656. In the same circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. So basically, again, pulling my standard circle over here, I have my two circles, and so what they're saying is, if you have a chord here, and let's just say it is 4 units away from the wall there, and then you have another chord over here that is also 4 units away. I know those aren't the same by drawing. Then they're equal. They actually have to be. Now, they said from the center, so let me show you what they are actually picturing so I don't make that up. Okay, you have a line back. Okay, so from the center, if this radius over here, and it's not technically a radius because it doesn't go all the way to the end, but if it is, well, they happen to draw a right angle on theirs, but if they go over here like so, and let's just say that the two lines are equal, so we say that this is 4 and this one's 4. Well, if in the same circle, two chords are congruent if and only if they are equidistant from the center. Those two lines are equidistant from the center. So these two things, let's say this one's 8 over here. I'm talking about the chord, not the arc. And then this one over here is 8 as well. That's all they're saying. All right, let's use it then. Here's example 4 and the last example for this. In the diagram, QR is equal to ST. So they said that this particular line, QR, is equal to this ST down here. Well, that ST, they're both 16. Then I guess we can do the converse. If the two chords are equal, then the two radii or lines that are coming from this must be equal. So I can say 2x equals 5x minus 9 because they're equidistant. I can set them equal to each other. Subtract 2x from both sides. There's a number for nothing. It's called 0. We get 3x minus 9. Let's go ahead and add 9 to both sides. Okay, that'll give me 9 equals 3x, and x will finally equal 3 for our final answer. So it says, find CU. Well, if we have x equals 3, how far is CU? You would say 6, hopefully, 2 times 3. And then, of course, if I check this, that's going to be 5 times 3 is 15 minus 9. You should also get 6. And so that's all there is to it. All right, looking down here, I'd like to go ahead and do some of these guided practice problems. Take a moment, pause the video, and let's have a little bit of a discussion on how to do those. But suppose that's the section. All right. One of the difficulties that you probably found here was that as you tried to do these problems, you might have struggled with, in the diagram in example 4, you're drawing a picture, and if you didn't see that particular statement, you're kind of done. So notice I'm drawing my diagram kind of the best I can, so you've got a chord, I said the best I can, and you can't erase it. So here's your chord, goes like this. Here's another one, and it seems to be going like so, kind of a little bit scant to that. They're both 16. Now I need to read the question first. Let's go ahead and get a center in here. And it says, let's go ahead and draw CV. And then we're going to draw CU. Okay. And those two things, when they actually hit the line, have to be perpendicular. So forgive my drawing skills. Now it says, in the diagram, suppose ST is 32. Well, let me get some more letters here. QR and ST. T. And this is an S. Forgive my letters. I really do apologize. And so it says, suppose ST is 32. So this bottom one is 32 now, this particular arc right here. And it says CU is CV are both 12. So this is 12, this is 12. They're equal. Find the given length of QR. Okay, so QR has to equal what? 32. Because they're equal. That's the rule we just learned. Now, going to the next one. The next one says, number 7. That's number 6 here. Here's number 7. It says, find QU. Well, says it's perpendicular, it has to bisect it. So QU is going to be exactly 8. And for sake of time, I'll let you figure out 8. A little bit harder, but for sake of time, I think we can skip that one over just for a bit. All right, let's talk about number 9. 659, number 9. Okay, you've got your two chords that are obviously equal, so you got 5x minus 7 equals 18. You would have done this on the board, I hope, but 5x minus 7 equals 18. Add 7 to both sides, you get 5x equals 25, and so x equals 5. Now it says, for this particular one, number 9, to find the value of the x. And so we've got x equals 5, we're done. So that's all there is to those particular problems. Very good. All right, so that concludes our lesson. So you'll take just a moment to write down this assignment, and we will be done. Here's your homework, page 657. Number 657 to 659, numbers 4, 9 through 11, 13, 15, 25, and 26. I'll see you next time.